Welcome to today's class. I'm glad you are there. I want us to look at base quantities and their SI units. Now, base quantity, just like how either you call it a base quantity or you call it a basic quantity, or we can call it fundamental quantity. Now, we'll talk about those quantities that cannot be expressed in terms of other quantities. We call them base quantities. We cannot express them in terms of other quantities. They are just there. Now, they are independent of other quantities. That is why we cannot express them in terms of other quantities. So those quantities are the mass, length, time. There are 7 of them: temperature, electric current, amount of substance, and light intensity. Now, so these quantities are the base quantity, the basic quantities we have in physics. So every other quantities we have in physics are obtained by a combination of 1 or 2 of them. So because of that, we refer to this one as base quantities. Now, the units of these quantities are called the base unit. That's why we say that a unit is a substance, is a standard size to which measurements are compared. These units enable us to identify physical quantity that is being measured. For example, assuming I have a quantity like mass, it is the unit of this mass that will enable me understand, or enable you understand what I mean by this mass. So, we can also say that the units of these mass are attached at the end of the measured quantity. For example, if I have 20 cannot make any meaning unless I attach meaning to it. Now, if I say seconds now, it means I am talking of time. So in other words, if there is no unit to any measured quantity, it doesn't make meaning. Therefore, we can say that a unit is that quantity that can make that measured quantity meaningful, or can give meaning to a measured quantity. Now, for the SI means System International. By System International, it means that whatever is measured for a particular quantity in one country can as well be obtainable in a different country. So it's a standard unit internationally. Now we have derived quantities. Just like we said earlier, any quantity that is obtained by a combination of 1 or 2 of these quantities will give us derived quantities. That is why we say that derived quantities are those quantities that are described in terms of other quantities. Or we can say that they are obtained by a combination of 1 or 2 of other quantities. Then the units of these derived quantities are called derived units. Now the difference between base quantity and derived quantity is that the units of these base quantities are single units. For example, we can have the units of these quantities. We can have the unit here. For example, mass. The unit of mass is just a single unit, which is a kilogram. Can be represented as kg. Length. The unit of length is meter, which can as well be represented as m. These are single units. Time is measured in seconds, represented as s. Temperature is measured in Kelvin, represented as K. Now, electric current is measured in ampere, because it's a Latin word, ampere. These are single units. Amount of a substance, mole, It can as well be represented as mole. Now the light intensity, which is candela, it can be represented with letter CD. Now these units are single units. Now for the derived quantities, since it's a combination of one or two, it can be doubled. For example, the unit of the unit of area is the unit of area. Of course, area is a derived quantity, and area is obtained by combination of base times height, base times height, or you can say length times breadth, any of the two. Since they are equal, you can say length times breadth. And of course, length is measured in meters, breadth is measured in meter. They are all lengths. So meter times meter will give us a meter square. That is why the SI unit of area is meter. Now we still have other derived quantities. Another example, this is example 1. Example 2, we can have volume. Volume is expressed as length times breadth times height. And of course, the SI unit for length is meter, the SI unit for breadth is meter, the SI unit for height is meter. So meter times meter will give us meter square, meter cube. That is why the SI unit of volume is meter cube. It's a combination of three different three different quantities. Now, number 3, we can have velocity. Velocity is expressed as a ratio of displacement over time. Ratio of displacement and time. And of course, displacement is measured in meters, time is measured in seconds. So which would now give us meter per second. Or we can have m first, since that is over here. If you send it up, it becomes raised to power -1. We can have, these are derived quantities. Number 4, we can have speed. And of course, speed is distance over time. Distance over time. Now, distance is measured in meters, time is measured in seconds, which will give us meter per seconds, or meters per seconds. Meters per seconds. Okay. Of course, velocity and speed. Most times we use them interchangeably because they have the same SI unit. But the difference is that one is a vector quantity, one is a scalar quantity, just as we discussed in our last video, where this is placed as a scalar quantity, this one is a vector quantity because of displacement. Or displacement is distance measured in a specified direction. We can have number 5 here. Number 5, we can have acceleration. Acceleration is expressed as velocity or speed over time. And of course, because velocity is a derived quantity, which is meter per second at the SI unit, time is seconds. Now, if we write this one on meter per second, send this one, it becomes another per second. Therefore, we can have meter, this will have S, -1 plus -1 will give us -2. That is why we have our SI unit as meter per second squared, or we can write it as meter per second squared, either of the two, either this or this. Number 6, we can have momentum. Momentum. Momentum is expressed as mass times velocity. Mass is in kg, velocity is in meters per second. Therefore, if we bring the two together, we have kg meter per second or kg meter per second, etc. and etc. Therefore, the other ones, we can have force. We can have number 7, we can have force. Force is expressed as mass times acceleration. Mass times acceleration. Of course, mass is in kg. Mass is in kg. Acceleration, which you have gotten as meter per second squared. If you bring the two together, acceleration will give us force will give us kg meter per second squared, or otherwise known as newtons. Newtons, which is represented as N. Now, it might interest you to know that, yes, force is measured in meters for convenience sake. However, if you are asked to write the base SI unit of force, we can take this as our base SI unit, but the derived unit is this. Okay, there are other derived quantities. There are other derived quantities such as we can have pressure, we can have, of course, pressure is force over area. Force over area is force is in newtons per meter squared, and all the rest of them. So this is where we are going to end the lesson today. But please, there are other ones. You can get to the other ones. Before we wrap it up, don't forget to subscribe to this channel. That like button, there's a like button there. Please hit the like button. Comment whichever question you have, write it in the comment section. Thank you very much.